Mr. Ahern land probably means 20 minutes, but we'll see. You guys know that there's no school on Friday? Isn't that cool? I didn't know that. I didn't know that until I looked at the calendar like 2 hours ago. So today's the 25th, and yeah, no school on the 28th, which is pretty cool. So today we're going to go back and solve quadratic equations again. So solving quadratic equations. By completing the square. I used to dabble with this in Algebra 1. Sorry about my word square up there in the corner. A little goblin took over my pen, but you know how to spell square, so it's all good, even if you can't read that. So what we know well at this point is we know how to solve quadratic equations if they're factorable. And I wouldn't write this part down if I were you unless you want to. An example of solving by factoring would be like x squared minus 4x minus 32 equals 0. So we would attack this with, if someone said, hey, I need you to solve this by factoring, then we would factor it down like this. We would know there's a plus and a minus. We would know, of course, that it's plus 4 and minus 8, and that the solutions then are x equals negative 4 and x equals positive 8. So you're pretty good at that. We've already gone down that road. We also have learned how to solve quadratic equations by using the quadratic formula. And that's another road that we've traveled down for quite a decent amount of time. So the third method for solving quadratics, I thought it was a good time now to come back to this, is called completing the square. And for this process to make any sense, you have to know first off what I mean by square. And you say square in any other context, and people think you're talking about a four-sided shape with 4 right angles and 4 congruent sides. But no, this is a square. And you might not believe that it's a square at first, but it is. So this will be a 5-minute, 3-minute, whatever detour before we actually get into the lesson here. But if I ask you to factor this, that should not be a problem, right? Maybe a little rusty on our factoring. Today will be good for a brush up on that. What would this factor down into? Times. Right. And what you notice, of course, in this case is that when you factor that down, you're like, ooh, snap, look at that. Those are the same. And so we would write our answer actually in this case as x plus 5 squared, hence calling it a square. X squared plus 10x plus 25 is a square because it is the result of something squared. That something being x plus 5. Here's another example of a square. Right? If we had to factor this down, what would it factor down into? X minus 6 times x minus 6. Again, it's sort of just inevitable when we go through the factoring process that the only combination that's going to work is a minus 6 and a minus 6. So they multiply to make 36 and they add to make negative 12. And again, we would write that acknowledging it as a square because it's something squared, right? Is that okay so far? Okay. So what we want is to understand that these are called squares and making them is the key. So this is a square. This is a square. I mean, I know it's like an oval on the board, but the thing that I'm highlighting is called a square. So the goal for the day becomes, how do I make a square? How do I complete the square? So if you're paying attention, let's see how this goes. I never know. This is like a roll of the dice. If I put x squared plus 8x, and then I put blank, you're about to do something called completing the square. What number would have to go in that blank to make this a square? 16 is the right answer. And I understand all of your answers. They were all good things. You're all saying neat things. But if you think about it, the only way that this can work is if this is a 16, because then it factors down into x plus 4 times another x plus 4, which makes that. And Brady knows what the algorithm is, and he's about to drop a knowledge bomb on us. What is it, Brady? Yeah, and I know you didn't mean to say square root. I know you meant to say square, but you did it. You cracked the code. The process for completing the square is massively simple. But as with a lot of things in math, it's simple if you like keep it tucked away. Like if you have a formula somewhere or you don't forget things easily, it's simple. And Brady just nailed it. The trick is to take your b, which is the middle term, if you will, and divide it by 2. So take the number 8 and divide it by 2. What do you get? Square that. What do you get? Jackpot. And that's how you complete the square. That will always work. Let's do it again. So let's say we have x squared minus 24x blank. This will never fail you, provided that there's not a number in front of x squared. That's later in the lesson. So what's half of negative 24? Negative 12. And what's negative 12 squared? So to complete the square in this case, we would need to add, we'd need to have a plus 144 at the end. And by this point, I'm sure you understand, like the top one would factor into x plus 4 squared. The bottom one would factor into x minus 12 squared. So the nice thing about this as we go through, and you'll appreciate this later on as we go and keep doing more and more and more, is that when you go to factor, what's fun about this is you can be the world's worst factor and you'll look like a factoring genius, because here's the idea. It looks like, we know it looks like that, right? So let's say I raise my hand proudly and say, man, I am terrible at factoring. That's okay. Let's go back to Brady's algorithm. What's half of plus 8? Half of plus 8 is plus 4. And that's how you factor. You don't even have to know how to factor as long as you understand the algorithm. Easy peasy, right? So I do it again, and I know this one's going to look like this. And I'm terrible at factoring, but it's okay. What's half of minus 24? Look at me. I'm like a factoring guru. So if we know how to complete a square, then it'll be simple then to factor what we created, because well, it's easy. Let's go one more time, and then we'll press into what we're actually doing today. So let's say we have x squared plus 20x blank. What's half of 20? 10 squared. There's your number. So to complete the square, you need to add 100. And it is now a square factorable trinomial. And it factors into, again, what's half of 20? So we want a plus 10. Boom. And what's nice here, take this to the bank, is that this sign that I'm pointing to with the yellow arrow will always mimic this sign right here. So if that one's a minus, we factor into a minus. If it's a plus, we factor into a plus. And I hope you agree by this point that this number at the back, the red number, will always be a plus because it's the result of something squared. That's inevitable. Good. Okay, so let's take a look now at our first actual example. So this next 5 minutes this is how you solve a quadratic equation by completing the square. This is what we do. I'm going to number these the order that I'm doing them in so I can be consistent throughout my day. I already have gone a little rogue off my plan here, so that's what I do. It's always nice in math to have steps, and some of you are very, very good about literally interpreting and memorizing steps. So here's step 1. Take your C term and kick it, vote it off the island. So that the next step in this is we're going to get a void at the end, you'll see. So when we transform this equation, it's going to say x squared minus 10x awkward void equals negative 22. We want to clear a pathway there for what you just showed me that you know how to do, and that is, here it goes, complete the square. So at this point, to heck with the 22, negative 22, whatever his name is, it doesn't matter. What number is going to go in this blank right here? Plus 25. And I'm sorry if you haven't cracked that code yet, but again and again and again, it will be the same. What's half of negative 10? Negative 5 squared is plus 25. Now, going all the way back to 7th grade, you learned that if you add 25 to one side of an equation, you have to add 25 to the other side as well. Good. Now, I need your help. So here I am telling you again, I suck at factoring. I'm terrible. What is this factoring nonsense? It's okay. What does the left side factor into? I have it underlined in blue. Go ahead. Jackpot. There it is. I'll circle this in yellow for you. What's half of negative 10? And that's where that comes from. Easy McSneezy. Now on the right, you got some fourth grade math to do. What's negative 22 plus 25? Very good. Any questions so far? This is where the magic happens. Yeah, Brady. It is not. It's far from the answer. Remember that we'll know we found an answer when it says x equals, right? That's always been the our green light, like our you're done signal. And so what I need to do now is I need to look at the x and say, I'm sorry, like you're stuck in parenthesis prison, but I can get you out. All I have to do is find some clever way to murder off that exponent. And how do you think we can kill that exponent? It's already squared. We can square root it. Very good. So what we're about to do is we're going to square root the left side of the equation, and we're going to square root the right side of the equation. Because if you square root a square, what happens? Just go away. And we can now say x and minus 5. The captain has turned off the seatbelt sign. You're free to move about the cabin. When they're bound up like that in the parentheses in the square, it's like stuck. But you get rid of that, everyone can go where they want. Now, on the right side, there is no nice square root of 3. Do we agree? So what we have to write here is positive negative square root of 3. And if you're inclined at this point to wonder, where did that stupid little plus, minus, positive, negative sign come from? Well, let me, up here in the corner, show you an example. If I said to you that x squared equals 49, you can understand that a guy like me would get upset if you just said that the answer is 7, right? Because isn't there another number that when you square it makes 49? Yes, and that's why we would implement that sign like right at that point in time, right there. That's worth putting in your notes. This moment right here, where you take the square root, is the moment that this sign has to come into existence. Are we done? Does it say x equals? Got to move the 5 over. So all we simply have to do now to finish the job is we have to move the 5 to the other side. And when I say move it, I mean very deliberately. Watch where I'm going to tuck it. This is not an arbitrary decision. I'm going to write x equals positive 5 plus or minus the square root of 3. And that's it. That means that if you had used the quadratic formula, you know, negative b plus or minus the blah, 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 you would have gotten the same answer. This way's a lot quicker. You might not believe that right now because I talk a lot, but it's super quick. Let's go again. That's it, done. Let's do x squared equals 2 minus 6x. This lesson's going to take longer than I pictured. And so I think I'll probably wind up switching it up and having tomorrow be some work time for you. So I'm calling an audible, calling it at the line of scrimmage here. What do you notice about this? Yeah, it's all messed up. So really a good first step. What would you think if I said this? Would that bother you? If it were quadratic formula, it would bother you, huh? Because you're like, I got to have everything set equal to 0 so I can find my A, my B, and my C. But you know what's coming down the pike. Like this isn't, if we get the 2 to the left side, we're just going to kick him back to the right anyways. And so now I've got the groundwork laid to complete the square. That's it. X squared and x, awkward void equals a number, and we get what we get. What number is going to go in the awkward void? Plus 9, because half of 6 is 3, and 3 squared is 9. So I'm going to add a 9 right here, and I'm going to add a 9 right here. Bless you, you just did something called completing the square. The rest of it now is just factoring and dinking around. The red number is completing the square. So help me factor on the left. I'm terrible at this. This factoring stuff, it vexes me. What does that blue thing factor down into? Yes. Equals 11. Very good. Next step. Got to root it. And remember, this is the moment where the positive or negative sign comes into existence. Not a moment before, not a moment after. We're going to say x plus 3 equals what? Good job. Positive, negative, root 11. Because we can't do anything with the root of 11. Last step. So we write that as negative 3. Right. You must always move your non-rooty term over in front of the plus or minus sign. And I'm not going to split hairs about this. For those of you that worry about things like this, I've tried to pick this fight and I realized I'm wasting energy. But if you're interested, what is that sign called right there that I'm pointing at? Just saying. What's it called? I'm pointing at it with a green arrow. It's not a plus or minus. It's called a positive negative sign. So like if I put this number down right here, read that number to me. What is it? No one would ever say -4. Well, no one in high school, right? We say -4. But now read this math problem to me. 3 minus 4. You see how it changes from being an adjective to a verb? So again, I'm not going to pick the fight with you, but technically at this point where the green arrow is, we say positive negative root 11. And then once we place something in front of it, it is now plus or minus. But I'm not going to bring that up again. That'll be the end of that. Okay? And I won't pick on you about that. All right, let's go again. Quicker this time. Think about where you want to put your parts and pieces. Who has to move? The only guy that can really stay is the x squared. He's like, I'll just watch you idiots do your little ballet thing over there. So x squared is like, I'll hang out. What comes after x squared? Minus 2x, and then an awkward void equals. Good job, you guys. Don't screw up that initial part. Jan makes the problem really awkwardly difficult when the initial baby stuff goes poorly. What's going to go in the blank? What is half of -2? -1. And what is -1 squared? +1, so I shall add 1. That algorithm isn't going to fail you. Half of b, square it every time. Maddie, that makes sense? Okay. It's time to factor. Your math teacher is terrible at factoring. I made myself forget how to factor on the way to work today. What does the left side factor into? X minus 1 squared. And as I've said, and I'll say it again and again and again and again, you don't even have to know how to factor, because what is, again, half of -2? I'm circling it up there in yellow. What's half of -2? And that's what you put there. Next step. Square root both sides, and you get x minus 1 equals what? Positive negative root 14. Next step. Move the 1, resulting in what answer? X equals 1 plus or minus the square root of 14. This number, I'll use green. When you move this number to the other side, you will always tuck it right there. Look at the little happy green arrow. Always put it there. All right, let's take a look at a couple other variations of this, okay? So that was example 3. You're going to notice something interesting about these next ones. What do we do first? Yeah, you can say either one. Subtract the 80, move the 80. We get what that means. So we're going to leave the x squared and the minus 18x. We're going to leave an awkward void, and we're going to put the 80 on the other side and rename him -80. By now, the algorithm ought to be clicking pretty hardcore. What's half of -18? And what's -9 squared? So I'm going to add 81 in the awkward void, and then I'm going to add 81 on the other side. I have now completed the square, and it's time for you guys to flex on my stupid math problem. How do we factor the left side? Yes. And if you still aren't seeing it, if you're still sitting there going, God, I wish someone else would ask how he's getting that again and again and again and again, what's half of negative 18? Then you just stick that in there. No questions asked. See what I mean? You don't even have to know how to factor. And then you put equals 1. Next step. Square root the whole equation, resulting in x minus 9 equals what? Positive, negative. Good. And no, I did not forget to put my root on the 1 because what is the square root of 1? So the reason this example is going to feel a little different, do you remember this in the quadratic formula when you'd get like -6 plus or minus the square root of 49? You'd be like, jackpot, the square root just like goes away. Well, here it is again. So the next step is robotically to move the 9 to the other side, and we get x equals 9 plus or minus 1. Now, as you would guess, that is not an acceptable answer. Why? Because you can do the math, right? What is 9 plus 1? So one of my answers is 10. What's 9 minus 1? My other answer is 8. And what do you think these answers mean in hindsight? You could have factored, but I don't want you factoring today. We're practicing completing the square, but that's what it means. All right, let's go again. Now, there's no reason in the world that you should have any idea what to do here, but I'm just going to throw this up here and see if you catch it. There's an intruder. Do you see him? The 2. And you've been around me long enough to know that when there's a number in front of x squared, that's not a little deal. That's a big deal. But I'm here to tell you, with completing the square, I am never going to ask you to complete a square under circumstances like this. So you might say, well, isn't that what you're asking me to do right now? No. We're going to divide everything by 2 because we can, right? Because that'll get x squared to not have anybody in front of him. So if you divide all the terms by 2, which is what you should do, what do we get? Very good, you guys. That's going to be a section of today's assignment or tomorrow's assignment, however it winds up being, is that you have to get that x squared to not have anyone with it. And the problems are very user-friendly. We're going to dodge fractions and things like that, at least for now. So what do we do first? Move the 5, add the 5, leave an awkward void. What's going to be the number that goes in the awkward void? Yeah, plus 9. Plus 9. Again, if you'd be so kind, how do you factor that left side? Totally. And on the right side, 5 plus 9 is? Next step. X minus 3 equals what? Good for you. Thank you for not forgetting the positive negative sign. That's a big deal. Next step. Final answer. When I'm not in the way of this process, mark my words, this is massively quicker than the quadratic formula. Do you buy that? I mean, I'm not going to super hard sales pitch you, but just take you'll see from experience that that is indeed a fact. Let's try again. Oops, I meant to write 4x squared. Take that back. I was looking at the wrong thing. There you go. I think so. Yeah, that's a good looking 56. I think. What does it look like, bro? But I certainly wouldn't put 5bx, would I? Fair enough. Step 1. Right. Divide everything by 4. We clear on that? Everybody get that memo? We don't want to be dinking around trying to complete the square when there's a number on the x squared. So if you divide all the terms by 4, what does that become? What does this become? Mm-hmm. And what does this become? Good job. There will be, just not yet. Not today. Do you guys, having sat through this now for a half an hour, can you see where the fractions would come from? Where would they, like, how would they happen? It could come from that step right there, but I'll tell you, like, here's one, like, just side note here. Could you divide all these by 2? So watch, you're not going to see any fractions, but you agree that you get this, right? But I can tell you right now that this one would involve a lot of fractions. Can you think of why? There's no half of 5. There is, it's called 5/2, and that's called a fraction, right? And so those are kind of not in play yet. So everything you see today, I used the term user-friendly earlier, and that's what I mean is like that b is always going to be even for your benefits, because then when you take half of it, you don't get a fraction. Okay? And it's not a big deal. It's just not something I want to cloud up today's lesson. I don't want today's lesson to be about fractions. I want it to be about mastering a process. So step 1, this will probably be our last example. I think you guys are good. So step 1, what do we do? Move the faux to faux. Leave an awkward void. And again, don't do rinky-dink 6th grade crap like forgetting to switch them to a negative. We just don't have time for that. And what's the next thing we do? What goes in the void? Add 49. Very good. That's half of -14 is -7 squared is 49. And then it's time to factor. On the left side, what does this factor into? Beautiful. On the right side, 5. Time to square root both sides. What do we get? Good job, you guys. Last step. Yeah, this is my favorite of all the methods for solving quadratic equations. The quadratic formula is nice. Some people fall in love with it because it always works. This is nice when it's meant to work. This isn't worth the effort if it's going to come out really ugly with weird fractions and stuff. But when the opportunity presents itself, this method is just beautiful. So, any questions? Your assignment is on the old Daddy Delt, the Delta math. That's what Cale Haas calls it, Daddy Delt. Calls it the Daddy Delt. Let's see how you do. You might actually get it done. I'm not sure. I don't remember.